Good afternoon, friends. We have a new topic on organisms and population. We'll discuss a small fragment of the concept, that is the bacterial growth. We know in the ecosystem it is made up of different types of organisms. Not only the human being, there are also microorganisms that is also taking part in the it's an integrated community system. Now the one problem is taken from the concept in the ecosystem. There is a given population of the bacteria. Normally, if you provide optimum growth condition, all the nutrients are available. In that condition, it will grow exponentially. Means if you take a population after n time, after t time, if at the beginning the population of the bacteria suppose 100 or 2000, 5000, whatever, it will grow in an exponential rate. Means it will grow just to the power of 2.7. So this is the normal growth curve for the bacteria. Now if you reduce the components in the bacterial culture, if they are lacking nutrients, their population will be automatically fall down. Consider that this population is growing without any fluctuations. Now what is the problem they have provided? If e to the power rt is given as a e to the power pi, means what is happening during the binary fission, r and t, this product is given as a pi, approx 3.14. Normally what happens, the range of r is in between 0.02 in case of a human population. It fluctuates from different individual to different individual, and as per the report in 1981, this r was given, and right now in 2018 this value is little bit changed, it's around 0.01. So what is the concept of R? It says that if a population with a particular individual at the beginning and their birth rate is B and death rate is D, then the difference between the rate is R. For example, if in a population birth rate is 0.75 and death rate is 0.5, so you are going to get 0.25 as the R. That is the intrinsic rate of natural growth. Means a population is it's capable to grow naturally if the external environment of the factor is optimum. Now the problem is given in this way: if nt equals to pi to the power e equals to n0 is given, it's not given, you have to prove it, it's less than 1, and e to the power rt is given as a e to the power pi. So in which state or in which condition you are going to get this kind of equation? Just you equate it this way: e to the power pi to the power e by e to the power pi is equals to n0. Now if this statement is true, we do not know whether this statement is correct or not. If this statement is true, then it's going to be this one. So as a result, you are going to get pi to the power e divided by e to the power pi is less than 1. It means this statement must be correct. E to the power pi is greater than pi to the power e. This will come to the left side. So we have to prove this statement without using any calculator. So right now we have to prove this equation is correct. If this equation is correct, we can prove that the initial population size is less than 1 or 100%. Consider this equation is correct, we'll follow some orders. If you are getting this relation is correct, normally these e and pi, these two numbers are not algebraic numbers. You cannot put some other algebraic expression because these are all transcendental number. These are not algebraic expression. So first you do one thing, you take log of both sides. You take ln of both sides. It will naturally come pi ln e is greater than e ln pi. Normally if you have two numbers 3 and 4, it's says that 4 is greater than 3, then log of any number x is always greater than log of y if x is greater than y. You can try it with the calculators, but here you cannot use the calculators. In the next step you can write ln equals to log base e it's equals to 1. So pi is greater than e ln pi. Then how to proceed? Normally pi is greater than e, That is true. 3.14 and E is 2.7. So can we say can you deduce something out of this relation? Pi is greater than E and pi is also greater than ln pi. Can we deduce that this one is true? No. Then we can do one thing. We try to find out the value of ln pi, because we know that pi is 3.14, E is 2.71. Only this value is unknown. Now there is a trick to find out the value of ln pi without using scientific calculator. You just replace it in this way. ln pi equals to 2.303 log base 10 pi. This is a correlation between the natural and common logarithms. Now, how to find this kind of value? Let it be x. Suppose this part is a x. Then 10 to the power x equals to pi. In the previous lecture, we have discussed that pi square is near to the value of g. It is the very near to the value g, the acceleration due to the gravity. So the root pi square is almost equals to root g. Now if you consider the value of g is 9.81, almost equals to 10, so we can write root 10 is almost equals to pi. Though it is not true, root 10 is greater than pi, but we can consider for the time being it's almost equals to root 10. So you are going to get 10 to the power half. Now x equals to half. So the value of this one equals to half. Because you have taken this one as x. If you cross check with the scientific calculator, you are going to get this value is almost equals to 0.49. So we have taken 0.5 here. So we can take it in this way. Now in the next step we will write in this way. Pi is greater than E 2.303 log 10 base pi. The value is here. So pi is greater than E 2.303 half. Multiply both sides with 2. So 2 pi equals to, greater than E cross 2.303. 2 pi equals to 3.14 into 2 means 6.28 it must be greater than, if our assumption is correct, then it must be greater than this product. We can consider up to 2 decimals. So what should be the answer? Make a calculation out of it. 2.71. Take it 2.71. Just to multiply 271 into 23 without calculator, because in this kind of exam you cannot use calculators. So it should be correct into plus 3 into 13813. It equals to 6.233. So it's coming 6.233. So this statement is coming correct. 6.28 is greater than 6.223. So our initial assumption is correct. So we can say, what we can say? We can say this one is less than 1 as e to the power pi is greater than pi to the power e. This concept is also applicable in the mathematical domain, where you have to prove this kind of equation. There are some very good mathematical channels, like you have a blue pens and red pens, and there is a one person, Press Tolakar, they also express this kind of equation by different types of methods. This is one of the simplest method, you can try it. So you are going to get this kind of population conclusion out of this kind of equation. Now, okay, so the last portion of this discussion is that when you study the population biology, or when we are studying the community and the ecosystem, we use two different types of formula. This particular formula that is I am going to write here, it is also useful in radioactive decay in the physics. What is that? Just repeat that one. If you just simply change this formula, just you put one minus sign in the power of E, this will be an indicator of the two things. One, either it is the declining population, the population will decline, or it is a sign for the radioactive decay. radioactive decay. I think this part is visible. But we must use here the plus sign because in the colony of the bacteria the population is growing up. So it must be e to the power plus RT. You can write this formula in the different format, equals to e to the power, as we know R is birth minus death rate. So it can be replaced in a different way. Now you can take log in both sides, so it will come in the different format. But normally what happens, this population doesn't allow this kind of growth. In any population you cannot see this kind of natural growth because the foods or the nutrient that we are supplying, that cannot be infinite. One day the resources will be finished. One day all the nutrients and the resources will be exhausted. In that case, we know that the population curve will be shifted to this S-shaped curve. It looks like a English letter S. So initially it was like a J letter. So normally the J letter represent the exponential growth. It normally represent, but a population, a normally stable population, will not allow this kind of growth for an infinite period of time. You can have it for the bacterial population for a short period of time, and after that it will fall down. In this case, what will happen? We normally get this kind of equation: dN by dt equals to. Now we have to take another concept here. If you provide a particular space, suppose a niche or population is growing in a particular space, you consider one parameter in the statistics. One is the K, that is the carrying capacity. Carrying capacity means in a particular geographical regions, the maximum number of individuals that can survive and reproduce and enjoy that particular habitat, that is a limited. Suppose in a population carrying capacity is 5,000 and in that population 6,000 people are staying, this is not accepted. So it is the maximum level up to which a population can grow. After that it will start struggle for existence. They will be just diminished. So in that case we replace the equation with this kind of formula: dN by dt into 1 by n equals to R. It's again little bit confusing because initially we used that R equals to B minus D. Now there is another expression of the same thing. We can use this formula, or suppose we don't have all the information regarding this, then we can use a differential equation. If you take the initial population as a n, so there is a simple formula: dN by dt means change of population number in a particular small amount of time. It can be represented as Rn. On the other words, you can write it here: dN by dt equals to R, you shift it as a reciprocal 1 by n. So we can use this formula for the normal exponential growths. But in case of a sigmoid curve, when the curve is for the natural human population or the population that will sustainable population, we use it in this way: dN by dt equals to Rn, same up to the exponential. Then you take some extra factor, that is the carrying capacity. So Kn by k. If you consider the total carrying capacity is 100 or 1000, you take it 1000, and the number of population is there, that is also 1000. So you can easily get 1000 minus 1000 is 0. That means the total expression will be nullified. It will be 0. That means a population can never grow after this limit. So if you take the population here as a k equals to n, this is the limitation of this limitation of the growth of the population. So in this case it will come here as a Rn into 0 by k. So it will be nullified. It proves that, see, this formula are nothing but the expression of the data that is being taken from a particular population. So just you put the data, just do some simple calculation, and you can make a conclusion out of this. This is the maximum limit a population can survive. After this it cannot be sustained. So this is the two different aspect of the growth of an organism in that particular different environment. Okay, so this is the end of the video. If you have any suggestion, you can just mail me in my email ID, or just you can upload some comments if you have any doubts, and you can also mail me the problems regarding this. Okay, thank you so much.